to make sure the recorder is on the right channel too. Whoa, okay. All right, so let's go ahead and get started with the class. I will start with the homework assignment that is due today, because I changed the due date because I want to go over the solution today in order for you guys to be ready for the final exam. So I talked about it in class last time, so that's why I kind of need to make sure that we go over the homework assignment, because it is really a good question to talk about for the preparation of your final exam. So what we'll do is we'll start with that one, which is actually a preparation for your final exam already. So we'll start with this one and go from there. Okay. Before I get started with the homework assignment, I do want to kind of mention why some of you may be having some problem with this homework assignment. So as we go with as we continue to talk about this homework assignment, I kind of want you to think about when you're doing the homework assignment, what is the obstacle? What is in your mind that is kind of stopping you from proceeding to the next step, or giving you confusion of, okay, I can see that there may be several ways to go about doing this step here. Why is there any doubt, or why do you think there are multiple ways to proceed? Because that's basically troubleshooting your own reasoning or your understanding of the material, which is good. Okay, that's the whole purpose of the homework assignment, is to get you guys exposed to the concepts of, okay, we have talked about all of these things already, but in this particular combination of all the concepts that we have talked about already, why is it problematic? Why do I have questions about how to proceed at that point? Okay. So as we talk about these things, especially on line 6, by the time we get to line 6, you will see that there are several times we have to go to line 6 for each invocation of sub 1. So the question is, how do we deal with line 6? That really should be the main question of this particular assignment. So I'm starting a new sheet for the trace, and I'll probably get rid of some of the toolbars that I don't need anymore. So this way I can fit more stuff on screen. All right, so we'll go ahead and get started with the labeling of the columns. There's one for comments, because we do have a condition to evaluate on line 3. And then we have line number. And then we start with the precondition. So the question is, are there any global variables that we have to deal with this particular homework assignment, with this particular pseudocode? So you start with each subroutine, and then you ask, okay, are all the names accounted for either as a parameter or as a local variable? In sub 1, we only have one name that we refer to, which is n. So n is referred to on line 3, on line 6 as well. But in either case, in all cases, n is accounted for because it is a bi-val parameter. Okay, so that means in sub 1 we do not have need of any global variables. In main, we have references to I. Well, no, we only have one reference to I, and I is a local variable, and therefore I is not a global variable. So that means in this particular program, we do not have any need of any global variable. Yes?
You said this was due on Thursday.
On Moodle, I forgot to change the date, but in class, I said it will be due on Tuesday. Yep. Because in class, it was due on Thursday initially, and then I said I will have to change the due date. I informed the class. We talked about it. So that is something that we have to. If I don't talk about it today, there won't be a chance to talk about it. That's the only reason. Okay, so there are no global variables for this particular program, so there's nothing to say about the precondition. And then we start execution on line 13, because line 13 is the first line out of the definition of a subroutine. There are two subroutines in this case. On line 13, we're invoking a subroutine called main. when we invoke a subroutine, there's either a return line number or return info cell. Okay, so you have to go with each one or the other.
Is it possible to have return info and return line number?
No, you have to choose only one or the other.
So you can't have both?
No, you cannot. You cannot have both because you only need one way to tell you when the subroutine is done, how do we go back to continue execution after the invocation. So that's why you only need one or the other.
So
yeah.
If the algorithm doesn't have return anywhere, you use return line number.
Correct. If the subroutine does not have a return statement to return a particular value, then you can use return line number. Yep. Excuse me, there's no food during the class. The water is okay, but not the granola bar. Thank you. Okay, so on line 13, we're invoking main, and then we have to set up the columns related to the invocation of subroutine main. There's the return line number in this case because main does not have a return statement. If you want to, you can use return info too, except in this case, the return info is going to be the same thing as the other one because return info is still telling us where to continue execution. In this case, where do we continue execution? Well, we're going to continue execution at post. So this time, the return info does not have a question mark in it because we are not expecting anything. There's nothing to make use of the return value of main, and main does not return a value either. But it is okay to use return info, just because it's return info gives us more information. Excuse me, the other way around. Yeah, return info gives us more information than return line number because it's not just indicating a line, but also what is on that line to do. But since post really has nothing to do, this is the same. And then we also have to allocate for the local variables. In this case, main has one single local variable I, and local variables in this class always start with an unknown value, and therefore we have to use a question mark to represent it. Now, in the final exam, if I ask you to trace something and you have to turn in the trace, you will have to follow all of the conventions that we do in class. Yep.
My question was that in one trace, is it possible to have return info and return line number?
In one trace.
Because you said that they're interchangeable. For this case at least.
You can always use one or the other, but for any invocation, you can only use one or the other.
Okay, so it is possible to.
Yep. But in this case, you will see that by the time we get to sub 1, we'll have multiple invocations, and then each invocation has its own return info. But we don't have a choice when it comes to sub 1, because sub 1 does have a return statement, so we cannot use return line number. Return line number does not have enough information for us to continue execution on that line.
Why did we use return info instead of return line number on 13?
I'm just saying that they can, in most cases, you can use return info in place of return line number.
Okay. What's the difference between them?
The only difference is return info gives us more information. It gives us the ability to specify what else is on a particular line to do.
Okay.
But in this case, there's nothing because post is post. There's nothing in post. So we can use return info or return line number. It still looks the same. So technically speaking, if you want to be really picky about this, we should put a colon here because post is the quote-unquote line number, and there's nothing on that line because it is at the end of the entire algorithm. Right, so now that we set up both columns for main as a subroutine, we now continue execution inside main starting on line 11. Line 11 is an assignment statement. But before we can perform the actual assignment, which is copying the value of the right-hand side to the left-hand side, we have to figure out what is on the right-hand side. The right-hand side is the invocation of sub 1, so now we have to invoke sub 1 to find out what is on the right-hand side. Then we can go ahead and copy that value to the left-hand side so that we can change local variable I. This is the time when return info is necessary because sub 1 is returning a value, and that value is used in return on line 11 to finish up whatever we have to do on line 11. So this is why column E has to be a return info. There's no option here. And the return info is not only telling us that we have to go back to line 11, which return line number can do already. Return line number can tell us where to continue execution, but only in terms of which line we are going to. But in this case, we are not only interested in going back to line 11, but we also need to know what else is on line 11 to do. So in this case, we have to specify on line 11, what is left to do is the assignment operation. The changing of local variable I still needs to be done. Okay. After we set up the return info cell, we can move on and set up the parameters. In this case, there's only one parameter which is passed by value. Its name is n, and in the invocation we specify 3 to the parameter n. So n starts with a value of 3. Here we go. And when you look into the subroutine sub1, it does not have any local variables. So these two columns, column E and column F, are all that we need to set up for this invocation. And then we can go into the subroutine itself, starting on line 3. Line 3 is checking whether the value of n is less than or equal to 1. Which n are we talking about? Well, since there's only one n, there really should not be any question. But we always look up we always look up a name from right to left. So in this case, even if there are multiple columns with label n, we still only use the rightmost one, as the n that we use at any point of the execution of the program. So in this case, the comment is simple to say n is less than or equal to 1 is false, because n has a value of 3, and 3 is less than or equal to 1 is false. Because the condition of a conditional statement is false, and there is an else branch in this case, we go for the else branch, which is on line 6. Line 6 has 4 things to do. It has to figure out what is on the left-hand side of the addition. It has to figure out what is on the right-hand side of the addition. It has to figure out the sum of the two values. And then it can use the sum of the two values for the actual return action. I cannot perform the return action until I figure out what is on the left-hand side and also what is on the right-hand side of the addition. I can pick either one in this case because it is not a logical operation. If this is a logical operation like OR and AND, I do have to follow the order of left to right because that's how short-circuited evaluation works. It has to go from left to right. For addition, subtraction, and stuff like that, the ordering is not specified for most compilers. And as such, you can evaluate the right-hand side first if you want to, or you can evaluate the left-hand side first if you want to. But you can only evaluate one invoke at a time, so you cannot do both at the same time. So in this case, since I'm reading from left to right, I would take care of the left-hand side one first. So that means on line 6, this is the part that I'm taking care of right now. I'm invoking sub1 again, using n minus 1 to specify n. So that means I'm invoking sub1 again. I have to set up all the columns that I have to set up when I invoke subroutine sub1. Yes?
For that first invoke sub1, and then n minus 1, and then returns to n, that, to me, it seems like 3 steps, but when we're doing it, it's only 1 step. I mean, because we turn it into a question mark.
No, we are not turning the n into a question mark.
No, from where right after return to invoke, from what's inside of those parentheses, that's one whole step, even though there's 3 things we're doing. We're doing
Can you name those 3 things? Can you name those 3 things that we're doing?
The invoke sub1, and then we're taking the value of n minus 1, so that changes that to a value, and then whatever we have from there turns to n.
Nope, that's
No?
it's one single thing that we are doing. We're invoking sub1, and we're using my n minus 1 to specify the parameter n for that invocation. But it is still one single thing that we are
It's just
doing,
one
which
step,
is
right?
invoking sub1.
It's 1 step because
We're invoking sub1, and we have to, but we do, as a process of invoking sub1, we have to figure out what is the value of parameter n that we are passing to the subroutine. Yep.
So will you be creating a new column for n, or will you just be modifying?
Well, you will see that we need to create new columns. Okay, that's basically what you have to do. Is the creation of or the allocation of columns is not done on a per subroutine basis. It's done on a per invocation basis. Okay, which means every time we invoke, we have to do exactly the same thing. It is not on a per subroutine basis, which means we only have to do it once for the entire subroutine. So since we're invoking it again, we have to allocate columns again.
But you would use the value from the previous n.
Correct. Okay, so let's take a look at what we are doing here. Okay, I think this will illustrate what we have to do. So in this case, we have to allocate one column for return info because once again we're invoking someone. We have to know what else we have to do when we are done with the invocation of someone. So in this case, when we're all done, we have to get back onto line 6. Now, if we're really just going back to line 6 and start all over again from the beginning of line 6, I can use return line number. I don't need to use return info. But that's not what we want to do, because when we get back onto line 6, the left-hand side of the addition will be done already. It will resolve to a single value. And we have the other side of the addition to take care of. So that's why we have to set up the return info cell like this, because the right-hand side is not the objective of this invocation. So that's why it is remaining as is, and it is inside return info cell, so that it is a reminder to tell me what else I have to do when I get back onto line 6 at this point. Are there any questions about the way I set up this particular return info cell? Questions? Now, every time I invoke sub1, I also have to pass a parameter n because it is expecting a parameter n. So that means I have to set up a parameter n here as well. We allocate the leftmost available column also for parameter n. So the question is, what do we specify here? We know that a by-value parameter is kind of like it's kind of like a local variable with the difference of it starts with a known value specified by the invoke statement. In this case, the invoke statement is line 6 or the left-hand side of the addition of line 6. It is passing n minus 1 to n. It looks confusing because we have several n's in the invocation itself, and we have several n's in columns. But the n on the left-hand side of the right arrow refers to the n that we already know. Which n do we know already at this point? Which column?
F.
Column F. So column F has a value of 3. 3 minus 1 is 2. So that's why when we set up the new parameter n for this new invocation, that n in column H starts with a value of 2. Yes, go ahead and ask the question.
Yeah, the n minus one. Why is it after sub 1? Shouldn't there be? Wouldn't a comma be helpful?
What wouldn't a what?
A comma after the invoke sub 1 comma and then n1 to separate.
But it is a part of the invocation.
Oh, okay.
It is a part of the invocation. Every time you invoke someone, it expects parameter n to have a particular value. So a comma separates, and say, okay, this is one thing to do, this is the other thing to do. But no, it is a part of the invocation that you have to specify parameter n.
So if there was a comma, you would make it 2 steps.
In pseudocode, it doesn't really matter. Okay, if you put a comma here, it's no issue, it's no problem. But when you move on to cisp300 and you put a comma where you think it makes sense and the compiler does not agree, then the compiler would not work.
Yeah, so a comma would kind of make it, right now it's 1 step, but a comma would make it 2, right?
But it is 1 step.
Yeah.
Yeah.
But I'm saying that if there was a comma, it would make it seem like 2.
That's why in this class you are not writing the algorithm, and I am.
All right.
So I don't have to deal with issues like, okay, what is this comma really doing here? Are you separating this into 2 steps? Like the invocation is 1 step, and then you specify the parameter as a 2nd step? But because it is 1 step, setting up parameter n is a component of invoking a subroutine.
Oh, it's kind of like the tool you need for that, right?
Say again?
Like the tool you need to do the.
You have to do that in order to invoke a subroutine.
Yeah. Okay.
All right, so now that we have column G and column H set up, we can now basically start at the beginning of the subroutine that we're invoking. Well, it just turns out that we're invoking sub1 from inside sub1. The fact that we're invoking sub1 from sub1 does not change a single thing. It does not change the mechanism of the invocation, does not change the way we are setting up the parameters. It doesn't change anything at all, okay? We still have to set up the columns exactly the same way as if we are invoking from somewhere else, okay? All right, so now that we are ready to start from the beginning, we have to go back onto line 3 and basically reevaluate n is less than or equal to 1. And as I mentioned a little bit earlier, when you refer to a name, you always want to look for the definition or the value of that name from right to left. In this case, if I look for n from right to left, the first one I see is column H. It has a value of 2. 2 is less than or equal to 1 is false. So that's why we go to line 6 again. When we get to line 6 again, you probably know what we need to do, because this is the first time we get to line 6 in this invocation. So that means this is a fresh arrival to line 6. We are returning, invoke blah 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 on the left hand side plus invoke blah 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 on the right hand side. So that means once again we have to figure out, okay, we have to figure out one or the other side first, either the left hand side or the right hand side. So I'm going to use the same convention as last time because I'm reading from left to right. I will also use the same order when I evaluate that expression from left to right. So that means we have to set up return info cell again, but this time I'm doing exactly the same thing. I'm taking care of the one on the left hand side first, and then we'll deal with the right hand side later on. So this is how we set up the new, quote-unquote, new return info cell. Yep, go ahead.
Since you haven't gone through line 4 yet, the value of the question mark hasn't changed.
That is correct. Yep. Okay, this is also an important point. When you get to line 6, the first time, like what we're doing here on row 11 of the trace, it doesn't matter that we already got to line 6 once previously on row 8 in the trace. It does not matter at all, okay? Because what you need to do is dictated by which line you're on at this point of the execution of the program. That is basically what is going to dictate what you have to do, not what we have done in the past. Okay? So until we have references to columns that are set up by previous steps and say, oh, okay, I guess we do have to refer to an earlier step, you do not look at any earlier step and say that, oh, we have been here before, so what do we do? This is the second time we get to this point. It doesn't matter. Because for this particular invocation of sub 1, this is the first time we get to line 6. And because it is the first time we get to line 6, you have to set up the columns exactly the same way as the first time we got to line 6 in the previous invocation, which is not even done yet at this time. Are there any questions about how we set up the columns? Let me change the setup of the spreadsheet, so this way we can focus on the current invocation of sub 1. Now, since we're invoking sub 1, we also need to specify parameter n, because every time you invoke sub 1, you have to give it its own parameter n. So parameter n needs to be set up, every single time that you invoke sub 1. It doesn't matter that you have been invoking sub 1, like you have 3 stacking, invocation of sub 1. Every time you invoke it, you have to set up a new n. So this time we are setting it up again using the left-hand side, which is using n minus 1 to specify this parameter n here. The n that we're referring to on the left-hand side of the right arrow refers to the n that we already know, and the one that we already know, starting from right to left, is column H. It has a value of 2. 2 minus 1 is 1, so that makes the new parameter n 1 in column J. Now that we are set up with both columns that we need for the invocation of sub 1, we can now move on and start execution from the beginning of sub 1 again. Okay? So we get back onto line 3, we check n, we see whether n is less than or equal to 1. And we look up n from right to left. Okay? And when you look for n from right to left, the first one you see is the one in column J, and the one in column J has a value of 1. 1 is less than or equal to 1 is true. So this time we go for the then branch, which is on line 4. On line 4, it is a return statement, and we already know the value that we are returning on line 4 because it is just returning a constant of 1. When we return a value, when it is time to actually execute the return part of a return statement, all we have to do is to look up the return info cell from right to left, find out which one is the right most active one, and it turns out to be column I in this case. Copy and paste the entire cell, and then change the value of the question mark to the value that we are returning. In this case, we are returning a constant of 1 on line 4, and that's all we are doing. Okay, we don't do a single thing after this on line 4. And then we proceed and say, okay, we're done with what line 4 is supposed to do. What else are we supposed to do in this algorithm? Not much. Okay, if you look at the algorithm, there's really not much that we have to do. The next thing we have to do is to get out of the conditional statement, and then we get to line 8. When we get to line 8, there are two things to do at the end of a subroutine. And what I want to make sure that you guys understand is why do we have two things to do? Okay. The first thing we have to do when we get to line 8 is to say, okay, we are now at line 8. It's the end of a subroutine. At the end of a subroutine, you have to figure out where am I supposed to go to continue execution. That really is the first question you have to ask. In this case, the return info cell of column I is telling us where we are going back to and what else is on that line to do. So that's why I'm going to copy and paste column I, or the latest value of column I, and basically say, let's make a note of what we have to do when we get back onto that line. And I forgot one thing here. I forgot to indicate what line number is in this case. So it is in line 6. I apologize for the omission here, because otherwise I wouldn't be able to know, where I'm actually going back to. So I have to indicate both the line number as well as what else is on that line to do. I might have omitted the same thing. Nope. Did I omit the same thing in the other one? Nope. Only with this one. Okay. So that's the first thing we have to do, is to make a note of where are we going to continue execution, since it is the end of a subroutine. The second thing we have to do is to say, well, now that we have made use of the return info cell and the invocation is coming to an end, no one needs to know column J anymore, because the parameter is only specific to this invocation of sub1, and this invocation of sub1 is coming to an end. And we already made use of the return info cell or column of this particular invocation, and as a result, both columns are now deallocated. And in class, we use this convention of using strike through to indicate the column is now, both columns are deallocated at this point. In the test, if I ask you to trace an algorithm like this from start to finish, instead of using strike through, you can exit out. But you do have to give me some visual clue that you are telling me that, okay, these columns at this point are deallocated. Okay, so you can either write it, do the same thing that I do in class, or just use a bar, just exit out. But you do have to indicate those columns are deallocated at the end of a subroutine invocation. Now we are back onto line 6, but line 6 doesn't look like the original line 6 anymore, because at this point the left-hand side is now resolved. The left-hand side of the addition is resolved. It is 1 plus something. I still cannot do the return part because the right-hand side of the addition is still an invocation of a subroutine. So that means at this point I have to invoke the right-hand side part. Is there a question? No. Okay. So at this point we have to invoke the other side of the right-hand side of the addition. So, well, what do we have to do to invoke sub1?
Solve the right side.
Sorry?
So to column 3.
Yep, we have to allocate the leftmost available columns, but we need two, one to specify the return info cell and one to specify the parameter, just like last time. Okay, so the mechanism of invoking a subroutine does not really change depending on the context. It's just that you have to be careful about the ordering of doing these things. Okay, every time we invoke, we have to allocate columns. In this case, every time we invoke, a sub1, we have to allocate one column for return info cell and then one column for the parameter n. This time, what do we write down in return info cell? Okay, return 1 plus question mark. Exactly, because the invocation that is being taken care of is the one that is replaced by a single question mark, because we're going to resolve it to a single value, so there's no need to write it down in the return info cell. We also have to remember that we have to specify parameter n. Okay, so let's take a peek at the n that we already know at this point. The n that we know already at this point is column H, because we are technically still using column G. Column G and column H is my current context. I'm setting up column I and J as the context of the next invocation of sub1. So if I'm using column H as the n of the n minus 2, which is on the left-hand side of the right arrow, 2 minus 2 is 0. So that means this column is now 0. Do we have any questions at this point about how we set up column I and J again for the invocation of sub1 on the right-hand side of the addition?
While tracing the algorithm, it would just help to look at it one line at a time like a compiler, instead of viewing the whole thing and getting confused at points.
I would think so. I mean, unless you have a pass by reference parameter, which specifically asks you to refer to a column, then you should focus on only the current context exactly. Yep.
I had a question, on row 16, it says 6 colon, return 1 plus the invoke. That's just reminding us of what value we got for that first question mark, right?
On row 16, you get this part here. Yeah, that part is basically what we are executing. We are attempting to execute this statement at this point.
Okay.
Now, in order to execute this statement, in order to finish the entire statement, which is the last operation is the return. But I can't get to the return part because I have to figure out what the sum is first. But in order to figure out the sum, I need to take care of the invocation of someone on the right-hand side.
But we write it like that to remind us of where we are so far with that statement.
That is correct.
Okay.
Yep. In the notes, I just simply use line 6, and then I refer back and say, okay, but line 6 doesn't look like this anymore. It looks more like what we had in the return info cell. But I'm changing the convention just to make it very, very clear, what we are trying to do when we are back onto line 6 on row 16. Because this is only the second time, we'll get back to line 6 a third time for this one single invocation of sub1. Okay, so now that we have set up both columns, we can now go back into the subroutine sub1 starting on line 3. On line 3, we still have to evaluate the same expression. N refers to the n that we look up from right to left. The first n that we find that is still active is column J. Column J has a value of 0. 0 is less than or equal to 1 is true, so we go to line 4 again. On line 4, we execute return 1. And all that is going to do is to copy and paste the leftmost active return info cell, change the question mark to a 1, and we are done. It does not matter that the return info cell is already specifying a return statement. It doesn't matter at all. Okay? We just focus, we zero in into the question mark and change that question mark to the value that we are returning. The rest does not matter. Yep.
Why is it 1? I thought we just got 0.
Because line 4 specifies return 1. N is 0, but the return value is 1.
Okay.
We are executing line 4, which does not depend on N at all. Now, how we got here depends on N, but what we do on line 4 does not depend on N. We're done with line 4. Line 4 is the only thing in the then branch of the conditional statement, so that means we are now ready to get out of the conditional statement and get to line 8. When we get to line 8, we have to do two things. One is to remind ourselves where are we going to continue execution, because this is the end of this particular subroutine. The return info cell of column I is useful for that purpose, so I'm just going to copy and paste it so that we know what we are supposed to do back onto line 6. And then the next thing we have to do is to say, okay, these columns are no longer needed because this invocation is now done, okay? Not the subroutine, this particular invocation of the subroutine is done. So both of these columns are now deallocated, and I need to change my context back to column G and column H, and the execution goes back to line 6. On line 6, at this point, I have returned 1 plus 1. Are there any further invocations to perform on line 6? We're all done. Both invocations on the left and the right-hand side of the addition are resolved. 1 plus 1 is 2. So this statement is really executing return 2. Okay, so we are ready to return a value of 2. What do we do when we return a value of 2?
Look for my rightmost return info and put a 2 in the question mark.
Yep, and that turns out to be column G at this point. So I copy and paste the entire content of column G and change that question mark to a value of 2 because we are returning a value of 2. Keep in mind that column B is telling us what to do. Column G in this case is telling us the result of executing the statement in column B. So you got to make sure that you differentiate what we are doing and the result of what we are doing. We're done with line 6 at this point. We get to line 8. On line 8, we got two things to do. The first thing is to figure out what we are supposed to do after the end of the subroutine. Column G, which is what we just dealt with earlier, is good for that purpose. So we are supposed to go back to we're supposed to go back to line 6 and finish up the right-hand side of line 6, or the addition of line 6. And then once we make use of the information of column G and end this invocation, then whatever we allocated for this invocation of sub 1 is no longer useful at this point, and as a result, it is deallocated. And then we can safely go back to line 6 and continue execution. But this time when we get back onto line 6, the context is no longer column G or column H, because column G and H are both deallocated at this point. So the context is now switching back to column E and column F. So let me turn this one down a little bit so we can see the context set up by column E and column F at this point. Okay, so we are executing line 6 the way it is specified on row 23. It is return 2 plus invoke sub 1, blah, blah, blah. Okay, can I do the return right now? When you look at line 6 on row 23, can I execute that return statement right now?
No.
I'm not quite ready to do the return part because there's another invocation that is left. So I have to take care of the invocation on the right-hand side of the addition at this point. So I have to invoke sub 1 again. So what do I have to do when I invoke sub 1?
Return it column.
Set up the columns, right? Okay, very good. So I'm setting this up a little bit differently, just so that I can show you both the context of what we're doing and also the columns that we're setting up. We are executing this particular invoke here, and to execute this invoke here, I have to set up 2 columns. What are the leftmost available columns at this point? I need 2. Column G and column H. Okay, we just deallocated those, okay, so we can reuse those at this point. So we have column G and column H to be used for return info and parameter n. What should I write down here in return info? We start with a line number. We have to go back into line 6. What else is on line 6 to do at this point? Return 2. Yep, it is already resolved. What about the other part?
Question mark?
Just a question mark. Exactly. Okay. What about n here? I'm setting up my new parameter n using my current existing parameter n. Yep, it's 3 minus 2, which is 1. Because the current context is column E and column F, which means the n on the left-hand side of the right arrow refers to column F. I'm setting up the new parameter n, which is column H. My existing n, column F, has a value of 3. 3 minus 2 is 1, so that's how I set up column H to become 1. At this point, both of those columns are completely set up, and I'm ready to execute the final invocation of someone. This is the last invocation of someone. Yep.
Is it okay on that column F, is it okay that next to that line 6 to put 3 just to remind ourselves?
Next to...
3, just, because you're getting so far down.
We're only on row 25.
No, but I'm just saying, just to know what 3 you're looking at. So on line 24, column F, is it okay to put a 3?
If you put a value in a column, at this point of this class, you're implying you're changing that. So that may not be a good thing to do, because I would misunderstand that as, oh, why are you changing that column to 3? Okay.
That's what I want to know.
Yeah, so what you want to do is just to look up the column and say, okay, what is the current value of that column? You just have to look up and see what is the last time you modified that column, and that value is the current value of that column. Okay, so we are now continuing execution. We are done with setting up both columns, so we can start with the first line in the subroutine sub 1, which is line 3. On line 3, the first thing we have to do is to say what is the result of the condition n is less than or equal to 1. Which n are we talking about? We still have 2 n's left. Well, we look up n from right to left. The first one that we encounter is the one on column H. So the n of column H has a value of 1. 1 is less than or equal to 1 is true. And as a result, we go to the then branch of the conditional statement, which is on line 4. Line 4 of the two, between line 4 and line 6, line 4 is by far easier because there's no invocation further at this point. So we just say, what is the rightmost active return info cell? Well, that's column G. We copy and paste it. We change the question mark to the value that we are returning, which is 1 in this case. We do not say at this point and claim that 2 plus 1 is 3. Let's simplify this to 3. No, we don't do a single thing about that. We just change the question mark. That's all we're gonna do. Okay. So at this point, line 4 is all done. When line 4 is all done, we are done with the inner conditional statement, or the only conditional statement in the subroutine. So we get to line 8 at this point. On line 8, once again, we got two things to do. One is to remind ourselves what we have to do after the end of this invocation of sub1. We use return info cell for that purpose. That's the whole idea. That's the only reason why we have return line number or return info cell, is to remind us what else are we supposed to do at the end of the invocation of a subroutine. But once we make use of this information, since we're at the end of a invocation, whatever we allocated for this invocation of a subroutine, we don't need it anymore. And as a result, both columns are deallocated. And when we are done with all the cleaning up, we can now continue execution on line 6. Line 6 is really just saying return 3 at this time, because 2 plus 1, we evaluate 2 plus 1 at this time when we execute a return statement. So we're effectively returning a value of 3. To return a value of 3 means that we have to locate the rightmost active return info cell, which is column E. So we look at column E and say, okay, this is what column E looks like. We copy and paste it, and then we change the question mark to the value that we are returning, which is 3. When we're done with this step, line 6 is all done, then we can move on to the statement logically following line 6, which is line 8. Line 8 is going to say, well, we need to figure out what else we have to do after the end of this invocation of subroutine sub1. I can use return info, the return info cell for this purpose. So we copy and paste this just to make a note of where we're supposed to go back to and what else do we have to do on that line. And then we have no use of these two columns anymore because this invocation of sub1 is coming to an end. So we basically say, let's deallocate both of these columns so we can reallocate them if we need to. And then we continue execution on line 11. The context, by the way, is now switched back to column C and column D because column E and F are now gone. So when we get back onto line 11, we say I is supposed to be changed to 3. But which I am I talking about? Look it up from right to left. The one that you locate first should be column D. Column D has an unknown value at this point because it is a local variable. We change the question mark to the value that we specify on the right-hand side of the assignment statement. We're done with line 11 now. After we're done with line 11, we move on and we say, is there anything else to do after line 11? Not much, okay? We're supposed to go back onto line 12. Line 12 is the end of a subroutine, and at this point, we have two things to do. We have to look up the rightmost active return info cell or return line number because we can use one or the other. In this case, we locate column C to be a return info cell. It is the rightmost active one. It tells us that we're supposed to go back to post. Okay, let's make a note of that. And then once we make use of that information, we are ending the entire invocation of main at this point. So we have no use of the columns that we previously allocated to main. I copied and pasted to the wrong place initially. So both of these columns are now deallocated because we are done with this invocation of main. And then we continue execution at post, which means we're all done. There's nothing on post that we can do because it is the end of the entire program.
So when you're returning a value, you just change the value of a question mark, not a certain
Yeah, that's the only thing we change is just the question mark.
So the variable doesn't matter.
That is correct. We do not execute what is inside the return info cell. Because I think that was your question, is if the return info cell is an assignment statement and has a question mark on the right-hand side of the the left arrow, what are we supposed to do? We only change the question mark, and then it is not time yet to execute the statement. We have to wait until we get back onto line 11. In other words, when column B specifies line 11 and we are ready to execute the assignment statement, only then do we change the variable to whatever we specified on the right-hand side. All right? So are there any questions about this particular trace?
Can you upload this as well?
Okay, well, we can do it now, okay? We'll go ahead and upload this trace at this point. But before we do that, one thing I do want to do is to remove all of these blocks here and change the zoom just so that we can see, you know, how big this really is as a trace. It is a little bit long, okay? You know, it's only because column G and column I are really kind of wide, you know, because we have to track what else do we have to do on that particular line. But other than that, you know, it only has 32 rows, and I don't think the bulk of this trace is the problem. I think it has to do with, you know, the ordering of things that we have to do. Are there any questions that I can help answer at this point? Yep, go ahead.
In the first half there, why aren't we exiting the conditional statement? We got false.
Okay, which row are we talking about?
Yeah, on the line 7 we got the conditional statement false, right? And then
On
second
line
time,
7 of the
Row,
algorithm?
row 7, she means.
Row 7.
row 7, yeah. We got false. Then on 10 we got false, and we kept going back to get the true statement, right? Like what we got on 13.
On row 13.
Yes.
Yes.
So why did we do that? If we have else statement, if we get false, don't we work with else and then
Yes,
we exit?
we got to the else, but we are not done yet. We cannot
My question
execute.
is why we not done?
Okay, what is the one statement in the else branch? Look at the algorithm, not the trace. On line 6, okay, line 6 is the only thing we have to do in the else branch, right?
Yeah.
But what do we do on line 6? Well, okay, it has got
Returning?
four
Oh,
things to
return.
do, right? It has got 4 things to do. The return is the last thing that we do, right? Before we return, what do we do? Immediately before the return, what do we do? The addition, right? But before the addition, what do we do? We have to figure out what we added, right? What is on the left-hand side of the addition? Invoke, yes. And what do we do when we invoke a subroutine?
So we have to find right?
When we invoke a subroutine, doesn't matter where we're invoking it from, what do we do when we invoke a subroutine?
We go back to 17.
Well, okay, there are several things that we have to do. First of all, we have to allocate at least one column for the return info or the return line number so that we know what to do after the invocation of the subroutine. The second thing we have to do is to allocate maybe additional columns, also from the leftmost available columns for the parameters and also for the local variable. If there are multiple, then we have local variables. After we set up the columns, then we continue execution on the first line of the subroutine that we're invoking. And what is the subroutine? What is the subroutines that we are invoking on line 6? What is the name of the subroutine that we're invoking? No. What is the name of the subroutine? What is on the right-hand side of the word invoke? Just look it up. Don't look at me. I don't have that name spelled out on my forehead. What is on the right-hand side of invoke? Sub 1, exactly. Okay, so we have to go to the beginning of sub 1 because every invocation starts from scratch. Okay, so when you invoke sub 1, you have to start execution from the very beginning of the entire subroutine. It doesn't matter that you come from sub 1. That part does not matter at all. It doesn't change the mechanism of invoking a subroutine.
Oh, I see now.
Remember, that was the very first thing that I said
Yeah,
when we
you
first
said
talked
it,
about
but
subroutines.
You said it, but I still didn't get it until I...
That's why we have homework assignments. And that's why I talk about the solution of the homework assignments. Yep. So that's good. It's good that you ask the question now instead of trying to figure it out in the final exam. Because I promise you there will be quite a few questions like these in the final exam.
That's hard. This one was hard.
It is not any harder than any other concept that we have talked about.
It is a little harder than anything that.
That means you have to clarify your understanding of the mechanisms. Remember what I said at the beginning of this class? I cannot remember either, but I can remember vaguely what I meant when what I said. Okay, I think I said, this is a chance for you guys to diagnose how you work on, traces like these. Okay, because if your trace doesn't look like this, you have to figure out why does it look like this. Okay, where does it start to diverge and say, okay, I'm going down this road here, but tech is going down this road. Why am I steering my car in a different direction? Okay. Now, I know it sounds like, well, tech, I guess, since you're the professor, you can be the only person that is right. But that's not even the case, because I am not even the person who is right. This is the behavior of a program when it is specified like this, regardless, almost regardless of the programming language. So I'm getting you guys ready for, any additional programming classes, regardless of the programming language that you'll be using. It can be Java, can be C++, can be Perl, can be Python. This is the way the program is going to behave. It is not what I'm saying. I'm only saying what the what the program is going to say in your future classes. With only one difference: I can talk and compilers don't. Compilers just don't run your program and say, "Oh, don't know what to do with this one." Done. Are there any other questions? I don't really mean to, say that, oh, you guys, still don't get this, because it is difficult. I know these concepts are difficult, so you have to basically crystallize your understanding of all of this stuff here, and basically say, okay, what matters, what does not matter, how come my trace does not look like this trace on the projector. Yep.
See, in my case, it's confusing for line 6 on the algorithm, because it says return invoke sub 1. So you do that using the value of n, which is 3, for the left-hand side. And then it makes n that value. But the thing is, for the second part of the invoke, we don't use the same value of n.
Yes, we
3.
do.
We don't use
Yes, we do. This n here is still referring to the same n as this n here, which is the same n as the n that is passed to you from the invocation, and also the same n that you use for the comparison on line 3. Those n's are exactly the same.
Yeah, what was confusing for me is like, I'm focusing on getting like down to the return, whatever the value.
But you can't do the return until you know what you're returning.
Yeah.
And to figure out what you're returning, you need to invoke the subroutine. And it just so happens that we're inside sub 1 and we're invoking sub 1, but that part should not bother you at all. Because what you're invoking is independent of what you need to do. It's the same mechanism. Whether I'm in sub 1 and invoking sub 2 or sub 3, doesn't matter, because it is still the same mechanism that you have to use. Okay. Any other questions about this one? I think moving on might be helpful, because if I move on to actual test questions for the final exam, you will get slightly more exposure. So I'm gonna save this file under a different name. I'll call that sub3 done, and I'll put it in the temp folder and upload it right away so that you guys can get to it. There we go.
There's no class on Thursday, right?
There's no class on Thursday. This is our last lecture, and that's why this class is kind of important.
Is it the same for classes on Wednesday?
Say again?
The same for classes on Wednesday?
No, if you have classes on Wednesday, you have one more lecture on Wednesday, because Thursday is the first day of final exam. So
Okay.
if you do have full semester classes on Wednesday, that usually meets on Wednesday, you still meet on Wednesday.
All right, thanks.
So I'm gonna add the file, and let's see down here. Okay, so this is sub3 done. Go ahead and upload it. I put it into the temp folder. Okay, so now we can move on to, I don't know how far we can go, in terms of the final exam questions, but I will start with this one. This one was particularly created for this class, so we'll start on that one. There are 5 questions on it. I'm not sure how many we can actually get through, so I'll let you guys pick which one we want to get started with. So we have, the first question looks kind of like what we're dealing with, except we also kind of mix in the concept of arrays. The second question is a pre and post condition one. We start with the post condition. I want you guys to figure out what is the precondition, but this is a conditional statement, which is something that we haven't done in the first exam. Then we have question number 3, which is not recursive. Okay, this one looks kind of more simpler because we have sub2, and inside sub2 we invoke sub1, and sub1 is not recursive. But what it does is it's mixing the concepts of passing by reference and the returning of a value. Those 2 concepts, by the way, are completely independent. They do not rely on each other, and it just so happens that we can use both in the same subroutine. So that's Q3. Q4 looks like this. Q4 is kind of interesting because it's recursive in sub1, but when I do the recursion, I'm crisscrossing the parameters. So what I pass to y, I use it to pass to x. What I pass to x, I use it to pass to y. And somewhere in between, I'm changing one of the parameters. And then we have Q5 here, which is another interesting one because we have the invocation of a subroutine as the condition of a loop. Yep, go ahead.
Do you have the answers posted up here?
No, I do not have the answers posted yet. The original plan was I can go through all of these questions in class.
Yeah.
Doesn't look like that will be happening. If I do go through all 5 questions in class, I'll be spending 4 minutes each, which may not be enough time to fully explain the concepts.
But will we be able to get the answers to these before the final exam?
Yeah, I will give you the actual solution to each one, but I cannot be explaining, if you just look at one answer. So as it is right now, which one do you guys want me to go through first?
Question 2.
Question 2.
It's been a while since we did that.
Okay, so we want to do I think that makes sense. Okay, going to question 2 first. Okay, so let's take a quick look at question 2. And question 2 is this part here. I'm just going to get this one out of the way so we can just kind of focus on one question at a time. There we go. All right, so this is question number 2. It starts with a post condition. I'm hoping that most of you can recognize where this is coming from. No, I have no recollection of seeing anything like this.
I recognize it, but we didn't do it in reverse like this before.
No, I pulled that out of that context, which is our factoring program. Okay, so when we try to figure out what is a factor of n, this is the conditional statement that we have to do after the loop. Okay, but I'm pulling this out of context just so that we can use it, as an example to illustrate how to do pre and post condition, so we can do it in a backward way and then the forward way. Okay, so what is given to you is a post condition. Okay, so when you look at something like this, I think with pre and post conditions, it's always helpful to draw a picture. It doesn't take much time to draw the picture, but drawing that picture can really help you understand what is going on here. This is a conditional statement, and all conditional statements look like this. Okay, it always has a branch at the beginning and always has a merge at the end. So that part does not change whether you have a multi-branch conditional statement, a conditional statement that has an else, or a condition that does not even have an else. A conditional statement that does not have an else simply says if the condition is false, there's nothing to do. You just skip all the way to the end without doing anything. But the then portion still has something to do here, so we'll specify something to do over here. So that's the basic general shape of a conditional statement that does not have an else that is specified. It's the same thing as an else, except the else doesn't do a single thing. Okay, so we have a true branch here, true branch, and a false branch here. The true branch is basically saying if f times f is in fact greater than n, we go to this side. So this is a question, is it greater than or not? Are we doing okay so far with this picture? Okay, it's a conditional statement. This is a picture that represents a conditional statement. So we can either go on this side or go on this side, but it doesn't matter which side we go to, we still merge and all exit through the same exit path. When we exit, which is post 3, we're basically saying at this point, n equals to 12 and f equals to 2. So that is given to you. I want to figure out what is the condition all the way up here, which is pre-1. And then we can use the pre and post condition, derivation to get back onto post 3 so that we can double check and say, okay, my precondition, seems to make sense. Are we doing okay so far with this? Okay. So given this is the case, we can go in, either direction. So to get to this point here, I can be coming from here, or I can be coming from here. Is that making any sense? Is that okay? Okay. So assuming that we came from the left-hand side, that means, at this point, we have n equals to 12 and f equals to 2, and that is basically post 2. Is that possible? Is it possible that post 2 is n equals 12 and f equals 2? If you look at the statement of line 2,
No.
is it possible that n and f have different values as a result?
Well, because if you plug f back into the top of the original equation, it would be 2 times 2 is greater than 12, and that is untrue.
Okay, well, but the question is, can this be the post condition of line 2?
No.
No.
Cannot be, because
N and F have to be equal.
they should be the same. Right, okay, so that means, this branch, that means we can stop here. Because there's no way this can possibly be the post condition of line 2. What about the other side? Could we possibly have come from the other branch? In other words, when n equals to 12 and f equals to 2, is the condition of the conditional statement false?
Yes.
Yeah, okay. So that means, the precondition of line 1 is the same thing. Okay, the precondition of line 1 is exactly just that. N is 12 and f is 2. That is the precondition. Am I doing okay so far? So? Okay. Now, starting with that precondition, now there's one more thing that you can add, but it really doesn't matter, is you can also say that at this point, it is also true that f times f is greater than n. But you don't really have to state that, because it doesn't add any more information. We already know that f times f is greater than n once we know the value of n and the value of f. So that means, the comparison, or the additional comparison, doesn't really add any more information to what we already have, so this part doesn't need to be there. Okay, so now we go forward. In other words, we look at this picture in a slightly different way. We draw exactly the same picture, except this time we start with pre-1 and not the other branch, not from the bottom. Okay, so this time we start with pre-1, and then we say pre-1 is n equals to 12 and f equals to 2. All right. So let's figure out what can be pre-2 in this case. Pre-2 is this one here. What is pre-2 in this case? Okay, so I can use my word processor for this part here.
Pre-2 is post 1.
Well, pre-2 by its very structure is going to be the same thing as pre-1 and the condition of the conditional statement, which is f times f is greater than n. Because that's the only thing that that's the only condition that can get us to pre-2, which is just about to execute line 2. All right? So since we already knew that pre-1 is n equals to 2, n equals to 12, and f equals to 2, we're adding this part here because that really is the condition of the conditional statement. But we end up with a problem, don't we? Don't we end up with a problem here? Because when n is 12 and f is 2, f times f is greater than 2 is false. So we end up with n equals 12 and f equals 2 and false. But anything that has a false, if you have a conjunction, can be a very long, can be a very short conjunction. But if a component of a conjunction is false, that makes the entire thing false. So that means the precondition of line 2 is false. It's a dead branch. from the perspective of this precondition of line 1? Well, that should not stop you from using the forget operation, because on line 2, okay, on line 2, f of, oh, I shouldn't use f here, because otherwise I'll be using f of f. Okay, let's use g of f. It's n. It does not have an inverse, because the left-hand side does not refer to the right-hand side. Use the forget rule. We can use the forget rule anyway. It doesn't matter. You can see that it's okay to use it. Okay. When we use the forget rule, it means the post condition is dependent on the forgetting something in the precondition. So we're forgetting something in the precondition of line 2. Anything that mentions f, which is the variable that we are changing on line 2, we have to forget. But on top of this, we also know one thing for sure. F and n should be the same at this point. And remember, do not use an assignment operation here. It has to be equality to basically say they are the same. We are not making them the same. We are saying that they are the same. What is pre2 again? Pre2 is simply false, right? And, okay, I guess you should spell it out here. False, false, false. Okay. Does false as a value mention variable f itself? Nope. Okay. If it does not, then false is just false, after the forget operation. So we have false and f equals to n. What is the result of that? Can we simplify it?
F equals n.
No.
False.
False and anything is false. Okay. So post 2 is false as well. Okay, great. What about the other branch? Well, with the other branch, which is this one over here on the whiteboard, this one here, what do we know about this branch? We know that pre1 has to be true at this point, right? So pre1 has to be true, but we also know the condition of the conditional statement has to be true as well. So in this case, we also know that f times f is greater than n. Okay? Now this branch is kind of tricky because it doesn't really have a name. Okay? It has no name to it. So in the test, I will give you basically a blank else case, a blank else statement. So that way you have a way to refer to that line and say, okay, this is an empty line, so the pre-condition and the post-condition are basically the same thing. Yep.
Why are we saying that f times f is greater than n is true on that side?
You're right. There should be an negation here.
Yeah.
It is not the case, because otherwise we would not be following the else branch, or the branch that corresponds to when it's false.
Okay, so we know pre-1, but did we decide what post-1 was?
There's no post-1, because post-1, there's no single post-1, because line 1 can skip all the way to the end of the conditional statement directly. So there's no post-1. But there is a post-3. So in this case, post-3 is post-2, or the entire thing that we just wrote down on the whiteboard, which is basically saying pre1 and the condition of the conditional statement being false. So it is not the case that f times f is greater than n. Okay, we know what post 2 is. Post 2 is false. Okay, we also know what pre1 is, because we figure out that pre1 is n equals to 12 and f equals to 2. So we have n equals 12 and f equals 2, and also the negation of f times f is greater than n. So we simplify this a little bit here. N equals 12 and f equals 2. The negation of f times f is greater than n can be rewritten as f times f is less than or equal to n. Okay. So if you give me this solution, I will consider it correct already. Okay, this is fine, no problem. But if we want to do any type of simplification, what can we do about false or something? It does not apply in this case, because with a disjunction, knowing one side is false doesn't tell you anything about the entire expression, because it's a disjunction. A disjunction has 2 chances of being true. So in this case, knowing one side is false doesn't do a single thing, but I can simplify one side out, because false or whatever is just whatever. It's kind of like 0 plus x is x. 0 plus whatever is whatever. So false or whatever is whatever. So in this case, I can simplify this at least, to this point here, and say, it is n equals to 12, and f equals to 2, and f times f is less than or equal to n. So if you give me this answer, it is considered 100% correctly. Even this one is considered 100% correct. Because
I don't feel like we followed the conventions that we normally follow though, because I feel like if you got to post 2, before you get to post 3, you should have a pre-3, which would set it up equal to post 2. Like I feel like we didn't talk about before today, which is
right.
the last class period before the final, doing it backwards.
How about this? I can give you. Okay, what about this? If I make it so that it looks like this, okay. Obviously the line numbers will have to change too. But what if I give you an else? And there's nothing here. Oops. And
Gibberish.
Gibberish, yes.
Gibberish right now. And I understand the pre and the post, but we didn't do it this way before.
Yeah, we didn't do it backwards.
Not
What
like
about this?
this.
Well, that's why it is, but we apply the same concepts, except we are doing it in a slightly different way. So if I do it this way, would it help? Because now we do have an else, and as a result, we have pre-for and we have post-for, right? And we did talk about how to do pre-for and post-for, for the else branch. Go ahead.
I was just wondering if one of the tests is also going to be using an if statement in it to do the reverse.
Yep. Yep. One of the other sample tests also have similar statements.
Are there notes on how to do this in reverse?
To do it in reverse, it's basically the same thing. You have to start from here, and then you say, okay, it applies to this side, it also applies to this side. But then you have to see, does it make sense to go through this branch here and see if I can actually merge it over here and see if whether it makes sense so that I can merge it at the end over there. Sometimes you can go in both directions. So your precondition becomes a disjunction because you could have gone back to the same point from both sides of the conditional statement.
I guess since this is 40% of our grade, it doesn't seem very fair to throw something new in there.
I agree.
Two new things. It's the first if statement we did while doing this too. I don't remember doing any if statements when we were doing this the regular way.
We have.
I mean, the if statement's throwing me off.
No, the if statement should not throw you off because we did do conditional statements when we talk about pre and post conditions. I have recordings of that. If you guys are interested, I can look it up and give you exactly what date and what time we did it. So going forward should not be a problem. Going backwards, maybe.
We are being tested on going backwards.
Well, I can change it so you don't have to go backwards. So I can do the backward part for you. I will still be presenting the question the same way, like we end up with this condition as a post condition of the entire conditional statement. And I would be doing the backward portion for you. But then you will still have to use the precondition to go forward again to make sure that we come to the same conclusion.
Sure. And why don't we have a post 1 again? And why don't we have a pre 2 but not a post 1?
We do not have a post 1 because line 1 has 2 ways to proceed. Post 1 implies that it can only go to line 2. But we can actually go from line 1 all the way to the end of the conditional statement.
Because if you execute line 1, like if it's false, you aren't going to execute it. So
Because you can go, this is line 1 here. You can either go to line 2, or you can go all the way to line 3, the end of the conditional statement. So I cannot really say of a particular post 1 because it can go to line 2 or line 3.
Okay.
But the way I changed it right now is I have a line 4, we have an else here, but the else does not do a single thing. So a line that is empty, that doesn't do a single thing, how do you relate the pre and post condition of line 4 the way it is presented on the whiteboard, the projector right now? How do you even have to think about the assignment statement stuff like the left-hand side, the right-hand side, and stuff like that for this particular line 4? It is an empty line. What does an empty line do in pseudocode or in any type of programming language?
Just goes right to the next line.
It doesn't do a single thing. So if it doesn't do a single thing, how do you relate the precondition of line 4 to the post condition of line 4?
They're equal.
They're the same, exactly, because it doesn't do a single thing. So the precondition becomes the post condition. So in this case, how do we figure out the precondition of line 4? It's the else branch. So how do we get to the else branch? The condition of the conditional statement has to be false to get to the else branch. So going forward, we have talked about going forward already. So that part, I know for sure we have talked about. So if I don't give you the question of going backwards, and instead I just ask you to go forward, you have everything, you have all the knowledge that you have already, I talked about everything that you need to know to go forward. So you have to apply that knowledge. It may be a long time ago, like about a full semester ago, but we did talk about that.
Yeah, kind of what you did before in the past is like, let's say, without all that there, you said, okay, the precondition is true or whatever, and then use the steps in order to get to.
I give you a precondition, then you have to figure what is the post condition of the entire conditional statement. Yeah. The only thing I said I would not ask is the post condition of a loop, which I will not. Okay, any questions about this? We are running out of time today. So what I'll do, if I don't do it, soon enough, like tonight, remind me to give you the solution to all of the questions in the sample test, in this particular sample test. The other ones I cannot really do because I cannot work on all of the sample tests that are released. But you should probably work on those as well if you want to. Especially if you work together, you can probably figure out something. But for this particular one, I will give you the solution to all of the questions. In the cases of you need to tell me details of specific things of a trace, I will give you the entire trace. Okay, so that way you know exactly what goes on when you trace those particular algorithms. And I still have office hours. Okay, so my office hours will be posted on my door. Tomorrow is a regular day, so my office hour will still be from 8 to 9 o'clock. And then on Thursday, unfortunately, the exam is the first thing that we are doing in the morning, so I won't have any additional office hours before the final for this class. Do we have final of this class on Thursday?
No.
Tuesday.
Oh, next Tuesday. Well, then you guys have several days to ask me questions.
When would we be able to ask you questions again?
My office hour would still be from 8 to 9 o'clock normally, but then on Thursday, because on Thursday it will still be from 8 to 9 o'clock.
Okay, so your office hours still the
So it'll
same.
be 8 to 9 on Wednesday and 8 to 9 on Thursday. The exam of this class is 8 to 10 in the morning on next Tuesday. Right? Let me just double check and look up. I don't trust myself these things. Final exam calendar. So today, this is a Tuesday, Thursday class. We start the class at 9 o'clock. So our exam is next Tuesday from 8 to 10 a.m. So it'll be a 2-hour exam. Bring your graph paper and bring a ruler because you might need that to kind of line the columns. Okay. I will supply the simple calculators. So I'll bring my bag of calculators with me. I don't think you will actually need it, but if anyone wants to use a calculator, I will have it available. Okay, but you have to bring your pencil, ruler, eraser, whatever you need, to do the test on paper.
Notes? Notes.
Open book, open notes. Okay, anything that is on paper is good. Do not bring any electronics, as a part of the test.
Okay, so this is my question here.
Yep. Let me turn off the recorder.
Okay.
Oh, sure.